Yeah. Hi everyone. Right now I'm going to discuss about calculating mean square error. So, what you mean by listening these three words, mean squared error? So, for this we need to understand coming from backward error. Error is the difference between the actual and the predicted value. So we are squaring this error. Error is y minus uh, y cap. We're squaring. Squaring means we're creeping a square, something like x into x square, right? And we are doing mean. Mean means a general meaning of the mean is mean, mean, is average. So if we go and see this, so this is the error y minus y cap. This is the error. We are squaring the error and we are doing the mean. It is the average summation by total number, right? That is the mean or average meaning. So MSE, the whole coming to the whole, this is the MSE, mean square error. MSE is largely used as a metric to determine the performance of the algorithm. So when, for example, if we take k nearest neighbor algorithm, which algorithm, which k value is giving the best fit, or which k, 1k, 1nn or 3nn, 10nn is good, giving good. 1nn means where the k value is equals to 1, and 2nn means where the k value is equals to 2. So once I'll explain the formula here. uh, Cn, the total number of terms for which the error is to be calculated. Yeah, where always we seem like a small n is the number of sample, capital N is the number of population. So y is the observed value and y cap is a predicted value. It's looking like y bar, but better to say like y cap. Why? Because y cap is generally used to predicted values. Y cap is the predicted value of y, or x cap is the predicted value of x. Okay. Why? Because x bar and y bar are generally mathematically used as mean. X bar is the mean of x, and y bar is the mean of y. So better to use y cap and x cap. Yep. How to calculate MSE? Calculate the difference between the each pair of the observed and predicted. Yep. This is called the error. Take the square of the difference. Take the square. Add each of the square difference to find the cumulative value. So he's trying to calculate the numerator. In order to obtain the average value, divide the cumulative value by the total number of items in the list. Divide the numerator by the denominator, where numerator is the cumulative, is the aggregation of squares of errors. Okay. I think you got it. So let us go to the code and understand it a little bit more. Here they're taking y as 11 and y bar. So y bar means predicted summation. N is the length of y. Yeah, so n is the length of y. This gives 5 for I in. Yep. So let me print. Yeah, MSE is 1.45. So if we try to understand this code from the bottom, okay, so they're saying like print of, if we keep this anything between the double quotes, then while we are doing this print statement, so that line comes first and later on the value comes. You can understand here the mean square error is 1.45. So summation by n is the length of y. Length of y is number of elements in y. It's like count of y in Excel and everywhere. Okay. Yeah. Summation is. Give me 1 second. Here they have written the for loop. So let us try to understand this for loop. Looping through each element of the list. Okay, difference y minus y bar. Square difference is difference square. Summation is summation plus square difference, taking sum of all the differences. Okay, that's fine. Pretty much cool. I hope you understood this exercise. Hmm? Uh, I'm trying to recap it. You're having two sets of data here, y and y cap. Y is the actual value and y cap is a predicted value. So you take the difference, y minus y cap, you get some values. Something like, if you take, for example, the first element minus first element, okay? 11 minus 12 minus 1, 2, 0, and oh, do we have here? See here, we have five elements here in the y, and here we have, oh, here also we have five elements. Great, okay. So this looks like minus 1. Next, I'm doing the difference here, 2, 0.5, minus 1, 1. Okay. We'll square them later on and do the average. That is the MSE. That is what we are doing during our code. Have a good day. Thanks for listening and watching. See you soon.